Hello. Hey, welcome back. Today we're supposed to be talking about foundations, and I've thrown together a quick little illustration here in SketchUp to show you what are the basics of a foundation. Now, a couple things you need to be aware of. This is pretty quick and not exactly perfect in any way, shape, and or form, but it's got most of the important parts here. So I'm going to talk to you. I left Helen in here this time, which I usually remove, just so you can get an idea of scope. Now, what I've done is a crawl space type footing, and I left it at a 48-inch tall stem wall. Now, let's start at the bottom so you understand what I'm talking about as I use some of those terms. So at the very bottom, when you go to build a home or any building, we start by excavating and establishing where the foundation is going to go, where the footings are going to be in the building, whether they're pad footings or spread footings. This is a runner. This is a spread runner footing, so it spreads across the weight across and then runs along the perimeter of the building and then through the building as needed. What happens is you'll end up excavating this portion right here is meant to represent the ground that we walk on, we stand on. So we excavate and we dig a hole and then we put in the forms and we pour the footing. Now, around our area, we form the footing. We don't just dig a hole or a trench and kind of roughly get it the right shape, lay the stuff in it, and then pour the concrete in. We actually form the sidewalls of it so we can make sure that it's stable and things. We do have some collapsible soils in our area and stuff we have to deal with. So sometimes these footings, they change their width. So in other words, they get broader this way, and sometimes they're not as thick this in the base. But this footing right here is probably one of the biggest keys to your whole house. Now, it's got to get below frost depth. So in every area, that frost depth is going to change. So we're going to go down into the dirt, however far it takes to get below frost depth. In some areas, like let's pick some place like Las Vegas. Las Vegas has a zero frost depth. It really doesn't ever freeze deep enough to get into the soil. So they actually can do a slab on grade, which literally means they can pour a slab on the ground. They just blade the ground off, compact it, get it level, put a slab on it, and they can get away with that in a lot of places. In our area, we have everything from about a 30-inch frost depth to 9 feet. It's 108 inches. Okay, so when we're talking about frost depth, it gets a little different. Now, if we're only going 30 inches down, which means from the grade here, top of the grade, to the bottom of the footing has to be at least 30 inches. I tend to go deeper than that just because, honestly, a standard form is usually 4 feet tall because they're made out of plywood sheets. So you might as well just do a 4-foot stem wall and then put your footing at the bottom of that. At least that's where my brain goes. But so as I'm laying this out, I'm thinking, okay, so I'll excavate down, I'll form up and pour my footing. Now in my footing, I get typically in our area 3 pieces of number 5 rebar. Those are 5/8 inch diameter rebar. And we lay them in kind of this V or reverse V formation that's spread so that when we put in the verticals that go with them, these are vertical J hook rebar, that they can hook in and out. In fact, this rebar should probably be up here, honestly, so that what happens is the first one goes in this way and the second one will go in this way as we're forming this up. And then as we pour the concrete, it sets and this bottom portion's held inside of these pieces of rebar. So as the forces act on this wall, these bending forces, okay, this has to pull out the whole footing to pull it out of the ground either way, okay? And these have to go in every 24 inches along this wall this way. And then we also put in vertical rebar in the wall going up and down. Now, lots of times we specify in our area to put in these rebars at the top that are basically your rim. Okay, they basically support everything up here. And then these are J hook or J bolts. They're 1/2 inch by 10 inch J bolts, and they go in the concrete when it is being right after it's poured. So what we do is we pour the footing, let it cure. And then we form up for the stem walls and we put in the rebar and then we pour that and we put these J bolts in the top of it. And that's basically your footing, at least as far as a normal crawl space footing in our area. Once those are cured, we'll strip the forms and then backfill. And as I rotate this around, you'll notice as we backfill, the backfill's it can be no closer than 8 inches, at least last time I checked. Now, I tend to go 2 feet here, honestly, because we'll start with the obvious. We get snow and we can have anywhere from 6 to 18 to 20 inches of snow, no problem, packed up against the house if we have storms come in one after the other. We've had storms that come in, sometimes drop 2 or a couple of feet in a night. So that's not a big deal to have snow right up here to the top of your foundation. Well, if it's the top of your foundation and it's wood from here up, that means you're sitting there as it's freezes and thaws. You got gaps, obviously, that'll show up right here and it'll get in. So I prefer to go with just a 2-foot reveal of my concrete here, which means that piece right there would actually be about right here, which would get me my frost depth a little shallower, but it still works. The other thing I do around here for the most part is if I'm pouring this much concrete, I would say do a basement. Even if it's unfinished, it's storage space. That doesn't always work if you're in a floodplain and stuff, but it's a good standard practice. Now, we pour this all the way around the perimeter of our home, and when we're done with it, it basically stabilizes everything. From this, everything else is piled on. So once this is done, we will actually undo the nut that would be on these. We would lay out a piece of pressure treated or redwood mud seal. We would drill the holes to match up, slide that plate, which is your mud seal, over those, put the 4-inch slotted washer on top of that, and then put the nut back on to hold it all down. And we definitely torque those down to the proper load, and then we would move on and start hooking our floor joists and rim joists on top of that. So that's the basics of a foundation, okay, at least as far as a crawl space foundation. Now there are other shapes you can get. Like I said, in some places you can end up with a foundation that is a slab on grade. Other places you can get a thickened slab. Now a thickened slab, I'm going to try to sketch one out here real fast and kind of quick, but I'm only going to make it about 2 feet deep, and it's just going to look something like this. It'd go across, let's go about 10 feet this way. Okay. It'll still come down. It'll still be a 4-inch thick slab. Bring it back over here. Now, quite often these, and a lot of people kind of cheat this, so I'm going to borrow a couple of things real quick. I'm going to attach them to that end. Come over this way, 8 inches, like so, straight up. Come on, get on that blue axis, you darn thing, and then diagonal. Okay, that a lot of times we end up with something that looks like this, and if I stretch it out so you can see what I'm talking about, and it gets the same kind of rebar in it and wire mesh through the floor and stuff. But what it does is it just basically it makes this a monolithic pour. You can actually form the outside and then lay in the pieces here, backfill it, compact it, lay in the rebar, and then pour this, and then basically surface this entire top edge, and you've got a slab on grade, but it's got a thickened slab footing for those areas that do have some frost issues, and it stabilizes it more. But that gives you a solid foundation upon which to build. Upon this, we can literally put in the J-bolts here, hook our walls to it, and just go straight up, just like normal. Those are a couple of the more common footings plans we see around here. We do see some cinder block with fill. We see compacted fill. In a crawl space situation like this, you definitely see the homeowner come back in, and they'll usually fill the dirt up higher than this. They'll actually bring the dirt up like so a little bit and then back over the surface here. Okay. Quite often, they'll fill, like how I said, this would have compacted dirt or gravel fill under it and road base. This over here would most likely in our area have some dirt fill over that, and then they would put on top of that anywhere from 4 to 6 inches, I have commonly seen from some people, gravel that they can then treat and help keep pests out of that and stuff. But it actually can also, depending on how the homeowner uses it, can give them a decent cold storage. Okay, so those things all have to happen. Now, one thing I left out of this, with this, because it would be a dirt fill under here, and in a basement that would have actually obviously probably some windows and some access to it, you don't have to worry about ventilation. In a crawl space, you would. Okay, dry rot. Okay, so when the wood gets wet and dries out and wet and dries out, it's going to lead to some rot issues just because of condensation and various things, vapor barriers that have to go in there. We want to make sure there's ventilation in these crawl spaces, just so we don't end up with any number of problems like sick building syndrome, like I said, dry rot problems, other bugs, pests, the neighborhood, raccoons, skunks, possums, what have you, trying to take up residency. So what we'll do is we'll usually put in various vent ports in these, and they have to, there's a requirement depending on your local building code of how much ventilation you have to have for every square foot of enclosed space under there. So make sure as you're doing these things, you review those. For the classwork we do, I pretty much say either do a thickened slab or a basement. Okay. Crawl spaces, we don't want to get overly complicated for some students right now with the backfill layers and then the vapor barriers and those things. So thanks for your time. And I'm going to hit the save button on this and we'll move on.